Hello, good evening, everybody. Mr. Prince, I've tried that stuff, so I want to assume that it's working already.
Oh,
I want to assume it's
okay,
working.
okay, that's great. Yes,
I want to assume it's working.
yeah, that's really good.
Yeah,
Okay, it's all right, Namdi. Thank you very much. Sorry, guys, I had a
you're
little
welcome.
bit of a challenge with the recording, so I had to ask Namdi to help me see if he can download OBS Studio and run. So he just confirmed that he supposes that it's working now. So we'll be using Namdi's recording for the day instead of mine while I try to sort it out probably after the meeting. So, guys, you're all welcome. Without much ado, I think we would start up. I would like us to start in earnest at exactly 7:05. Of course, others can join us while we have started so that we'll be able to do the much we can within the hour as expected. So, guys, you're all welcome. This is supposed to be our a statistics call. We're supposed to address issues relating to statistics, especially as regards the sprints that we have already covered. So it is more like a revision session where we'll touch down on things that we have done. If there are challenges you have in the MCQs, in the sessions we have done before, in your private study sessions, anything that you have tried to do, and anywhere that you have had any challenge, please, this is the time to bring them up so that we can address them. Mainly, the main people who would be addressing our questions to is Mr. Isishe and Mr. Adekunle. That is Oludare and Nandi as we know them in our pod. So please, guys, bring on your questions. They will start something generic first. I don't know what they have in store, but I believe that they would start something out while we get our questions ready and ask them. So thank you, guys. We are starting right now, 7:06. So you guys have the floor. Thank you so much.
Hello, everybody. Good evening to you all once more. Please, I will love that we have a highly interactive session this evening. But because of the interference that we may be having when two or three persons try to talk at the same time, I would strongly recommend that we make use of the chat area once you want to, contribute or ask a question. But if it's very important, then you can go ahead and unmute yourself and speak. I hope I'm audible enough. Please, you can drop it in the chat area if you can hear me. Thank you. Hello, guys. Please, if you can hear me, I would like you to just say something in the chat area. And I hope my environment is not too noisy. Josh, I beg no verse, I beg, I give me something. All right, so thank you very much, guys. So let's quickly look at it. And again, this evening, I would like us to be very specific towards what, just like what Mr. Okun said, towards what we've learned so far in this sprint on statistics, and also from what we are expected to do in the MCQ. Although nobody is here to give out the direct answer to the questions from MCQ, but I want to believe we've all gone through it. At least we agreed this in the last meeting. That let's go through the MCQ questions, and so that we have idea of what the issues we'll be discussing in this session this evening. So before before you drop your questions and before the main interaction will begin, I want to first of all commend Mr. Dari on what he has done so far. He has given a kind of breakdown to those those complex terms in statistics, like talking about the the hypothesis testing, the Z table, the distributions, and so on and so forth. And I think in the last meeting he also mentioned central limit theorem, a bit of it. So I just want to ask some big questions. I'll be asking a kind of rhetorical question and providing answers to them. Those are some of the things you should look out for and some of the things you have to understand when it comes to the statistic we are actually learning right now in the sprint. So the very first question I want to ask, and I don't know if you've gotten basic understanding about the concepts or the questions I want to ask. If you don't have the basic understanding, like I said, it's going to be more of a kind of rhetorical question I'm asking, not for you to answer directly. I'll also give a brief answer, and then we can discuss. Okay, I hope that is cool. Alright, having said that, my first question would be, why do we sample? That's my first question. Why do we actually sample? Because from the beginning of the course, you'll be seeing statistics, sample versus population. You hear things like sampling distribution. You hear things like the sample estimate, or the statistic rather, and so on and so forth. So why do we need to sample? Now the question, remember I said it's going to be kind of a rhetorical question. I will ask and I will answer. The reason why we have to sample is to get good estimate for a population. We sample because we want to get good estimate for a population. The next question that we want to, arise from this answer: since we have a population, why don't we look at the larger population and get whatever fact we need from that population? Why do we have to go through the route of sampling? The answer is in the notes, the notes on statistics that we have in this print, which is that is sometimes, in fact always, not sometimes, always very expensive, difficult, computationally expensive, difficult, and not always possible to get access to a whole population. I hope we are making sense. Please, am I communicating, guys?
Yes, Nandi, you are. You are. You are.
Okay, okay, very good, very good. So, since that is a very huge issue of relating with the population, therefore we need to sample, and from the sampling we can now we can now talk about the population by getting a good estimate. Now there are two keywords when it comes to sampling and population, and I want to believe that you've seen that in the note or maybe your personal studies. The two keywords are statistic and statistic and parameter. Those are the two keywords: statistic and parameter. Yes, I think it's in one of these notebook that you've seen. So statistic is just the result you get from a sample, while parameter is the result you get from the population. So we are trying to get a good estimate for population parameter. That is why we sample. Okay, having said that, now I asked that question because I was going to talk about the normal curve, or the normal score, or the Z score rather. The Z score or the normal. I know Dari has said some things about it, but please, I would like us to take note of what I'm saying, because we'll definitely see some of these things when we try to answer those MCQs. And some of you also agree with me. You must have seen some of what I'm about to say in the MCQ. So let me go back to what I started with. Why do we sample? I said we sample because we're trying to get a good estimate for our population parameter, right? Okay, having said that, I'm going to share quickly I'm going to share in a moment. I'm going to share uh, a white screen or a kind of a board where we would use for communication. Just give me a minute. Let me launch it. All right, guys. I'm still here. I'm trying to launch the board. Just give me a minute, please. Okun, this particular app we are using for the screen recording, if I
Yeah.
open another window, will it capture that window?
Okay, depends. If you want to open another window, open a
Yes.
new window. Don't open a tab on this environment that you're working on, the browser you're working now. Don't open a new tab, otherwise it will show. It will work or it will be showing on that tab. Just open a new window. So anything you want to do outside here, do it on that window. Then it will record only this window.
Okay, I actually want it to show it. Let me see. This I'm doing
Okay,
now
if you
is
want
what?
it to show it, then open it on this tab. Something on the browser, open on this very tab.
Okay,
Or cast it just like you do your normal casting.
all right. I don't know what I'm.
You
What is
understand?
wrong?
Cast it
Yes, I
as a
get.
presentation from this Meet environment.
Okay. Uh,
Yeah.
what is all this nonsense technical issues now? Okay. Just I'm trying to open a kind of white and a board that we use. I don't know why this my system is misbehaving now. So all these things are what you face when you are seriously doing something. That is when your system will decide to misbehave. The system will not misbehave before
Sorry about that.
using it for something very important. It's my alt tab key that refused to work. Oh. Okay, I think it's working
Oh,
finally. It's working finally. Alright, so I think we are almost there. Where are we? Okay, so uh, my row. Mm, okay, good. So we are here.
Standard, are you presenting?
I want to do that, but before presenting, I want to
Okay.
open the board. Okay, so I think we are now good to go. Let me now present my. Let me present this window. Okay, here we are. All right, guys. I don't know if you can see my screen. Can you all see my screen?
Yeah, yeah, I can
okay, we
see
Okay,
can
it.
see your screen and
very
we
good.
can.
So this is what I want us to do right now. I'm going to pick a pen. So we're talking about uh sampling, right? Now in real life, there are most times the kind of data we work with, right? When you get a distribution, when you try to study the distribution of the data, the distribution don't fit into the distribution of the data we work with most times don't fit into a normal curve. In real life, most times distribution we work with, they don't fit into a normal curve like this. I hope you can all see my normal curve, the bell shaped curve. So what do we do in that case when you're trying to work with a data set and you have a distribution that's not fitting into a normal curve and you want to actually study that population or that sample? You want to study the sample. Of course, we say we cannot study the whole large population because of the size, but we have to deal with sample. You want to study the sample and get a good estimate for the population parameter. Now, one test or one distribution that is well known is this Z distribution or the Z score. This bell curve, the Z distribution or the Z score is well known to all. But in real life, most data set you get or sample you get will not ordinarily follow this distribution. So what will then be our guide? Or before I move on, I hope you guys know the meaning of distribution. When I say distribution, you know what it means. In case of those of you that may not understand, I've not gotten the meaning of distribution or what it means. I believe almost all of us, if not all, took did statistics in secondary school at secondary school level. Now, if you know of frequency distribution table, if you've had the times where you say calculate or construct a frequency distribution table, that is the simplest form of distribution you can think of. Am I making sense? That is the simplest kind of distribution you can
Yes,
think
yes, you're
of.
making sense.
Good.
Yeah.
So whenever you hear distribution, I don't want you to think of something so big or so large that I cannot comprehend. Distribution is as easy as a frequency distribution table. Okay. So and in that at that level, to secondary school level, I believe you must have attempted a question where they say construct a histogram for this frequency distribution. That is where you have to draw a histogram or histogram for a data set, and you have something like this. Something like this. Can you see this? Now, this is a perfect example of a distribution. This thing you see here is a distribution. And when you look at this distribution, it doesn't follow the normal curve. Because if it follows the normal curve, then what you're expected to see will be this. What you're expected, if it follows the normal curve, you should see something like this from a distribution. Am I making sense? So you should see something like this. Now that
Of
is the
course, you're
reason.
making sense.
Good.
Yeah.
Now that is the reason why we need this normal curve. So now, how if the sample does not follow a normal distribution, what do we then do to use what is known? We know the Z table. We know how to calculate probabilities from the Z table. The Z table is there. So what do we then do to make that particular sample actually follow that Z curve, so that we can use the probability table, the Z table, to calculate probabilities of some certain event happening from that particular sample, such that that event will be used to judge the entire population. That is what will lead into what is known as sampling distribution. Sampling distribution. Should I ask my question again? I don't know if you guys understand what I'm trying to say. The question is, we want to study population at large. We can't do that. We can't afford to look at the population at large. We have to go into sampling.
Yes.
Once we get a sample, most times in real life, the sample distribution does not follow a normal curve like this. It doesn't look like this. It's not always like this. So the question is, what and there is a normal curve that we know. There's a normal table that we know that can give us probabilities of events happening. You get? So what do we then do to that sample that we have, so that the sample can follow the normal curve and we can get some statistic from it that will be a good estimate of the population parameter?
Okay.
So are we following? So
Yeah, yeah.
that will lead into what is known as sampling distribution. So instead of working with the actual distribution of the sample or the population at large, because the population will not have that distribution, instead of working with the actual distribution of the population, we get some samples out of the population,
No.
right? Then
Uh,
then then we
well,
get
let
some
me.
samples out of the
Let,
population, then construct a sampling distribution. When we construct the sampling distribution, now central limit theorem will now come into play. The theorem now says that the more samples you choose, the better your sampling distribution, or the closer it is to a normal curve. Let me give one example to explain that point, then we'll move on to something else. I'll just give one. You have to understand the concept of this sampling and sample distribution for us to be able to think of what happens if sample size increases, what happens to the interval level, what happens if sample size increases, does it have any effect on the mean of the sample, is it going to be good or not? So if you understand what I'm about to explain, then you can answer those questions. So here is it. Let's say we have a whole population, right? And this population has a distribution that is not normal. Say the distribution is something like this. Here is the distribution of the population, right? So it's not normal at all. And we need to make some inference on this population, but because we can't work with the entire population, we need some sample. We need to get sample out of the population and work with this sample. Alright, now we are taking sample from a population that is not normally distributed, and we need the normal curve to make our inference, or to use to make our conclusion on whatever sample we are drawing. So what we then do is, instead of just picking this sample and working with this sample, we would now say, okay, I'm going to pick this sample, say sample containing, let's say, 4 elements, 1, 2, 3, 4. I'll pick this sample with the 4 elements. Let's use figures, let's use numbers instead of just drawing circles. I'll pick this sample with the 4 elements, 1, 2, 3, 4, 1, 2, 3, 4. Then I'll construct, if my statistic is if my interest, the statistic I'm interested in is the mean of this sample, then I'll compute the mean of these 4 data, which is the number of this 4, n here in this case is 4. I'll compute the mean and obtain a value, right? So that value is known as x bar. So I've computed the mean already of this sample. Okay, I'll compute the mean x bar. Then I'm going to get that mean. Okay, I'll store the mean somewhere, then get another sample of another 4 data, 1, 2, 3, 4, compute the mean, store the mean somewhere. So we have x1, we have x bar 1, x bar 2, x bar 3, x bar 4, x bar 5, and so on and so forth. So once we have all these means, instead of working with this distribution, we are going to get a distribution for this mean, all the means, x1, x2, x3, x4, and that will form a distribution of that will look like the normal distribution. And the more n we pick, the better our normal distribution is. From there, we can now make our inference using the Z-score and the probabilities, or the probabilities on the Z table, to talk about our sample that will be a good estimate of the population. Okay, having said that, I will show you one other experiment, one tool that I found so useful to also explain this point. But before I go to the tool, I don't know if you guys understand what I'm trying to explain right here, talking about sampling, because this particular curve you have here now is now called the sampling distribution of sample mean. Sampling distribution of sample mean. I'm writing this in so rough. Why? Let me do it neatly. This curve is called the sampling distribution of sample mean, the sampling distribution of the sample mean. So, do we understand what I'm trying to explain? Even if it's just a faint idea of what I've said here before I show you the tool I'm about to show to you. And from that tool, you will appreciate the the size of n to making the sampling distribution normal and getting a good parameter estimate. Please, do you understand before we move on?
Yes, Namdi, I understand so far.
Okay, good. I've seen your
Right on.
question.
I'm having ideas. Right on.
All right, I've seen your question, Okun. So I'll go to the question, but before that, you give me a minute. Let me share with you guys that tool I talked about. So let's look at this. I believe you can all see my screen right now.
Yes, we can see the screen.
Okay, good. So here we have histogram of means with its corresponding normal distribution. So this is a sampling distribution containing just two number of the mean, the number of sample is 2 in this case, n equal to 2. So we're saying this is the analytic value of the mean. That means this is expected to be the population mean, the population from which this sample is drawn. So here is the mean, and here is the population variance, 336.51. So if we use just 2n number of samples, if you just pick 2 and compute the mean, or number of times we this is sampling time, number of times we sample, okay, number of samples, yes, 2. We have a mean of 299.76 and 39.426. So let's see how increasing the sample size will give a good estimate of the population. Can you see what is happening? I'm increasing the sample size right now. So this is when the sample size, that is the number of samples I pick, is 285. Now how many samples of size 285 do we have in this case? There are 5 of them. So if we increase the number of samples, see what is happening. Can you see? And don't forget that the histogram here, each of these bars here represents the samples we are picking from that population. So look at how good that histogram is fitting into the normal curve as we increase the number of samples we pick, and see how close the sample statistic is to the population parameter once we change this value as we are increasing this. And also, if you increase n, size of n, which means how many samples do we pick from each of those, what is the size of each of those samples? Did you see what's happening? When you also increase this number of samples, it also fits into that normal curve. So if we are able to get a good number of, if we have a good sample size and a good number of sample, we can get our distribution to fit into the normal curve, then use whatever facts we know about the Z-score and the normal distribution to make inference on our population. Now back to Prince's question. Prince asked that what is the difference between the normal distribution and the T distribution, which is also known as the student T distribution. The simple difference is the number of sample n. If you have the difference is the number of sample size, rather sample size n. If you have a good sample size or a large sample size, theoretically we take it to be sample size that is greater than or equal to 30, then you can use your Z distribution to make inference about the population that sample is drawn from. But whenever you have a sample size that is less than 30, then you will need to make use of the T distribution. Let me repeat myself. Whenever you pick a sample size of, when you're working with a sample, a kind of sample with size n which is greater than or at worst equal to 30, you make your inference about the population using the Z distribution. But in a case where you have a very small sample size, say sample size of 5, sample size of 4, sample size of 10, of 20, then you have to make use of the T distribution. The process of calculating the Z score, the process of calculating the T score is the same thing as the process of calculating the Z score. When you are carrying out an hypothesis or a particular experiment, the process involved in setting your hypothesis, the null hypothesis, the alternate hypothesis, and performing your calculation when trying to get a particular doing your research using Z score, Z distribution, the same process is involved when you are using the T distribution. The only difference is when the number of sample is small or the population variance is not known. So you have to use the T score in that kind of situation. I don't know if I've answered Prince's question.
Yeah, Nandi, you've answered. Thank you very much.
Okay,
But I have one more question,
please go
if you
ahead.
don't mind. Okay, it's regarding the Z distribution, which you
Yes,
just showed us,
yes,
which typically follows a bell curve format or form.
yeah,
Now, I want to find out, is it that because there seems to be so much emphasis on the normal distribution,
yes,
that is the bell curve distribution, is it that it is majority of statistics would fall into that curve? Because you said that there is something you need to do to make your statistics, to make it conform to that curve. Hmm?
hmm,
That you have to increase the number of sample size or the number
yes,
of n, so to speak. Am I correct?
yes,
Now, does it mean that if you increase the number of n, it
hmm,
will definitely fall into a bell curve format? What if you increase the number of n population and it still does not, because that is the nature of the sample? Let me give you an example. If you are carrying out a sample of weights in a group that are majorly maybe pre-selected to be tall people, no
yeah,
matter how you increase the size of the n, the population of those tall persons will be mainly tall people. I
hmm,
don't know if you understand. So
yes,
what if after increasing n, maybe because of the nature of the population you're dealing with or the sample that you're dealing with, it still fails to conform to the Bell format, because there seems to be an underlying assumption that it will always conform. Is that the
yes.
case? Does it always conform?
Yes, Prince, thank you for that awesome question. So, what it means is that I've not been able to do my job well to explain the meaning of sampling distribution to you guys. No matter the kind of distribution the population you are working with follows, no matter how ugly the distribution looks like, by Central Limit Theorem, when you have the when you collect samples from that population that has very ugly distribution, doesn't look anything like the normal distribution, you pick the first sample. Okay, now you pick the second. Now mind you, you are not just picking that sample, Prince. Like for the example you gave, you say you are working with top people, you won't just pick a sample of top people and expect that sample, one single sample, to have a kind of normal distribution. Even if you like, you pick 100 samples from that population of top people and just get the distribution of the samples, you will not get a normal distribution. But what you will use instead of using the distribution of the samples you are picking, you will use the sampling distribution of a statistic of the sample. You will use, let me come again, instead of using the distribution, just get a distribution from those samples you are picking from the population. You are going to use the sampling distribution of a statistic of the samples you are picking. For instance, you pick a sample of 10 persons, the height of 10 persons from that your population, the ugly population that doesn't follow the normal curve at all. You pick 10 heights. What you will do is to get the mean, the average of those 10 heights. You keep it somewhere. You pick another 10 heights again of the same sample size. That is 10 because you pick the first 10. You pick another 10 different 10 heights. You get the mean. You keep it so you have mean number 2. That's what I was trying to explain. You pick another 10 heights. You get the mean. You have mean number 3. You pick another 10 heights. You get the mean. You have mean number 4. So when you do that, it is the mean of those samples collected that you form a distribution that will definitely be a normal distribution, provided you have a large sample and you have good number of trials. You did that particular selection good number of times. That is what the central limit theorem is saying. I don't know if you understand. So when you do that so in that case, since you are getting the mean of each of the samples you are picking, you pick 10 different heights, you get the mean. On that 10 heights, you get the mean. 10 heights, get the mean. So you are constructing a distribution of the mean of those samples. So in that case, we call it the sampling distribution of the mean sample mean rather. We call sampling distribution of the sample mean. There are situations you have to use the sample median. You call that the sampling distribution of the sample median. That is, if you pick the 10 height and you get the median, pick the other 10 height, the next 10 height, get the median, So in that case, you are now using the sampling distribution and not the sample or the population. So according to the central limit theorem, that sampling distribution will definitely follow a normal curve, given that you have a good number of samples. So alright, having said that, do you have more questions? And the effect of that is this: the more the sample you have, and remember I said for the example I gave you, pick 10 height. If you make the height 20, the more the sample, the smaller your interval, the narrow, okay, let's say the smaller of your variance. The more the sample, the smaller the variance, because that the bell shape, the bell curve will be getting closer, be going closer and closer and closer to the mean. And what it means is that it's also affecting your confidence interval. Your confidence interval will be reducing, meaning that you can confidently say, you have a high confidence, not confidently say, you have a high confidence of saying that this sample mean, for instance, can be used as a good estimate for the population mean. No, I'm not presenting. Okay, what are you saying now, please? What are you guys saying? For now, I'm not
Okay,
presenting.
we're not seeing a presentation.
No, I'm not
So I
presenting for
think
now.
Michael was trying to let you know that you're not presenting, and I'm
Okay.
telling him that it's intentional.
Yes, I'm not presenting for now.
You
So I'm
had
just trying to.
presented a while
So
before.
please,
Yeah.
guys, do you understand the meaning of this, the idea of this sampling distribution, and the difference between the Z distribution and the T distribution, and when to use those distributions? Please, do you understand, or do we need other? Do you have other questions? Please ask questions if you do have questions.
Can you go over the Z and C distribution?
Come again.
I'm trying to use
Okay, how to use the
Can
Z
you go?
distribution.
Yeah, the
All right.
explanation and how to use them, or rather when to use them,
Okay, very
when
good.
and how to use them.
Okay, thank you. To start with, I want us to note that there are different kind of Z table. I'll come back to that. Let me answer Daniel's question. So for the Z distribution, when do we use Z distribution? That's a good question. Let me present my screen and show you when you know that we have to use the Z distribution for any hypothesis you're trying to test. So I'm back to my board. I hope you guys can see my board. Now I can't see the message box now. So if you are going to respond to my question, you just say a yes or a no, please.
Yes, yes.
Yes, now we
Okay,
can.
okay, good. So now he's
Yes.
asking, when do we use the Z distribution? If you have a population that is normally distributed, I'm coming. If you have a population or a sample that is normally distributed, and when we say something is normally distributed, how do you know that the thing, a particular set of or a particular sample is normally distributed? You collect the sample. Most let's work with figures now. Let's say your sample contains numbers. You have your sample 1 1 3 1 5 2 1 3 1 2 4 5 1 2 1. Now let's say this is a sample of some scores, some kind of data you've collected. So if you want to know if this thing is normally distributed, the simple thing you need to do is to plot a frequency plot a histogram for this sample. Plot histogram for the sample. And what is histogram? Histogram is just like a frequency distribution. Frequency distribution. That is going to be the histogram. So it means your data. How many points do we have here? We have our data points 1 2 3 4 5. 1 2 3 4 and 5. So this is the this are the data we have, and this, your vertical column will be the frequencies. Okay, so frequency we have 1 2, let's say 3. Let's stop at 3. How many ones are there? 1 2 3 4 5 6 7. There are 7 ones, so that is 1 2 3 4 5 6 7. You draw a bar to 7. How many twos do we have in this data? 1 2 3. There are 3 twos. You draw a bar across 2. How many threes do we have? 1 2 3. There are 3 threes. You draw a bar across 3. How many fours do we have? 1. You have just 1 4. How many fives do we have? 1 2. There are 2 fives. So can we say this particular sample is normally distributed?
No, no, no.
No. So this sample is not normally distributed. It is skewed to is
The
skewed
right.
yes, it's skewed to the right, and we call this kind of skewness a positive. Is positively skewed.
So why are we saying that it's not normally distributed? Is it because it's
Because
skewed
it
or
doesn't
because
yes
there's an
it,
outlier?
because it's skewed and it doesn't follow the
So it
normal
doesn't follow a
curve
bell
like
curve.
this. If the data,
Okay.
yes, if you by the time you construct a frequency distribution, you see it looking like a bell shape, something like that, then you say it's normally distributed. But right now this particular sample is skewed, so you can't, if you want
Okay.
to make
Okay.
any inference concerning the population this sample is drawn, you cannot make your inference based on the normal. The normal table is just a table of probabilities. So you can't make any inference based on the normal table, and you cannot make inference based on this t-test also, because these are the two tools, one of the two tools we have in making inference concerning the population: the Z and the t table, the t distribution. You can't use any of those to make inference. So what do you need to do in this case? So in this case now, you have to
Namdi, please, I have a question.
please ask.
Sorry to
I can't hear you
cut.
clearly. You are breaking.
Okay.
I still can't
A
hear
quick
you.
one.
Okay.
A quick one, please.
Yes.
So, distribution, is it that because of the shape of the bell curve,
Wow. Wow. I wish I can hear you. I don't know
does
if
it mean
I'm the only one.
the
I can't hear him too. That's it.
Please, you have to come again. You have to come again, please.
McDonald, please, if you can hear us, just use the chat box so I can read out your question. Just use the chat box and read it out so we hear.
Okay, guys. Are there
Okay,
more?
maybe you can continue while
Okay,
we are waiting for
please.
McDonald's question.
Are there further questions? Other questions, please. Let's begin to ask questions now, so that we know how to. Okay, okay. I think the other person that asked question said, "When do we use?" So I said, "When to use is when your data is normally when your data is having like the frequency distribution of your data is like a bell shaped, has a bell shaped. If you see that kind of a stuff, then you know use the normal distribution or the normal table or normal distribution in general, and the distribution itself or the how to calculate the z score. The z score is used in making inference. Don't forget. So how do you calculate the z score? You know the formula. The z score is equal to maybe mu or x bar minus mu, depending on what it is, depending on the values you're working with. Let me use mu minus x bar. So we have mu minus x bar over over sigma divided by the square root of n, where this sigma is the population standard deviation. This x here is your mean, that is the sample mean, and this is the population mean, and here is your sample size. With this formula, it will help you calculate the z score. And what does the z score tells us? The z score simply explains the number of standard deviation, the number of standard deviation a statistic or a, I just want to use the generic name now, statistic. When we say statistic, please, statistic can be a mean, it can be a median, it can be mode, any description or any descriptive value from the sample. Everything has to do with the sample. Am I making sense? So z score simply means the number of standard deviation a statistic is away from a population parameter, I'm using generic names, but if we are interested in the mean, the number of standard deviation the sample mean is away from the population mean. That is what this z score is all about. Now with the z score, you now have to go to the z table to get the probability of that sample mean being that far away from the population mean. So let's go into the table right now. There's something I noticed about the table that was shared with us in that in the notebook, in this notebook. I don't know if any of you have discovered that too. Let me open the notebook before I share my screen. Yes, here is it. Please, what do you guys notice about this table I'm about to share? Do you have any comments on this table and the examples given in this note? Do anybody have comments on this table and the examples given in the note?
Um, I think I just noticed that if you look at the value for 2.0, the positive 2.0, and add it to the value for the negative 2.0, you are going to get a 1.
Okay, okay. So have you tried to look at the example, this example given on Central Limit Theorem? They said the food land shoppers example, where they obtained, they said the area between z equal to 0 and z equal to 2.5 is 0.4938.
493.
Yes, do any one of you understand how this value was obtained
Okay.
from this table?
Yeah.
I think after getting the Z-score,
Yes.
typically the way you would obtain the value is to use the Z-score
Mm-hmm.
and the probability of I've forgotten what that is called anyway,
Yes,
but that is the value that is 0.9. So the
that is the level of,
probability, the chances of it
that's
happening.
the level of confidence. Oh, sorry, the alpha significance level.
Aha, the level of confidence. Mm. You take it and you check it with the Z table
Okay, let's do it together now.
and
Let's do it together, please. I want you all to look at this. Now, after calculating,
oh,
this is the formula for the z-score formula I just discussed. That is the mu minus x bar
yes.
over the square root of, over the sigma and square root of n. That is what was done in this particular part. I don't know if you guys can see that clearly. Can you all see my screen clearly?
Yes, please,
We
I
can
can.
see though it's a bit small, but at least we
I'm
can
increasing
still
it.
try.
I've increased it.
Oh,
Is it better?
okay, okay, better.
So the
Yes,
z
better now.
score formula was used here, and we obtained a z score of 2.5. Okay, which means that, let's see the question. The question is, food land shoppers have a mean of 60 rands groceries bill with a standard deviation of 40 rand. What is the probability that a sample of 100 food land shoppers will have a mean grocery bill of 70 rands? So you are getting 100 sample and you're asking what is the probability that they will have a mean of 70, but it is known from the norm that the mean is 60. Okay, this is the norm. The norm is that the mean is usually 60, so with a standard deviation of 40. What is the probability that when you sample 100 food land shoppers you will get a mean of 70? And this is where you have to apply the z table. Okay, now, but we are not told of the kind of, since we don't have data point now, we are not told of the kind of distribution that the population is having, and we don't even care about the population distribution. We don't care. All we care about is what is the sample size, since we know a theorem that is known as the central limit theorem that has informed us that whenever we have a large sample we can use the z score, meaning that when you decide to go and look at the population, if you have the opportunity to see it and get a sample, get different do sampling of n size, that sorry, of sample size of 100, different sampling of sample size of 100, and get their means, you get the distribution of the means of those sampling. The distribution will be approximately the normal distribution. So we are assuming, we are working on that assumption now, because our n is sufficiently large, is greater than 30. So we want to now get a probability from the z table. Let us know how true, or what is the likelihood that this particular mean is actually 70 rand. All we have to do is to apply the z score, and that is what this, you can see we apply the z score right here. Okay, this is the mean of the sample mean minus the population mean. You can decide to turn it. You can decide to use either population mean minus sample mean or sample minus population mean. Since you have the negative z-score table and the positive z-score table, and they are all going to be the same. Okay, so the sample mean minus population mean divided by the standard deviation, which is 40, divided by the square root of the sample size, which is 100. So square root of 100 is 10. 40 divided by 10 is 4, and they obtained 2.5. Now this 2.5 means, what it means is that this 70 rand is 2.5 standard deviation away from this 60 rands. That is what it means. And you can say the other way around, that the 60 rand, which is the population mean in this particular case, 60 rand here is population mean. The population mean is 2.5 standard deviation away from the sample mean. That is what he's saying. So now, what is the probability that this is actually true? What is the probability that this 70 rand is actually 2.5 standard deviations away from the population mean? We have to answer that question. We have to move on to the Z table. We look for 2.5 on the first column, which is the Z value. That's the Z value 2.5. Because this is 2.5, we just go under 0.00. And when you come to the table 2.5.00 from this table that was given, you will see we have the value 0.9938. That is the value we have on the Z table, 0.9938. But when you scroll down to the solution again, look at the solution. What answer did they give to us? They said that we can compare a z-score of 2.5 to the table of normal curve areas. The area between 0 and z equal to 2.5 is 0.4938, which is not the same thing as what we have here. What we have here is 0.9938. So do anybody know what is going on? What is wrong? What is happening here? Any idea? Am I still on this call?
You are.
Okay.
Namdi, you're still on this call.
So I'm not hearing anything.
We are listening. That's why you're listening. Want to understand better.
Oh no, do anybody? Okay, so that means nobody knows what is going on there. Because why I'm stressing this is because we are going to. There's a question in the MCQ that you have to use. You have to go to your z-score and look at the value. But what we are saying here is contradictory. From the table is different from what we have from the solution given.
Okay. Does he have a reason why it's contradictory?
Yes, that's a reason.
Yeah.
And the reason is because
Can I attempt?
Okay, please go ahead, Prince.
Okay, I'm thinking that it is because the the hypothesis that was put forward, it is invalidating the hypothesis, so to speak. That is what I feel. Because
What
if
is
that
the
z-score is 0.99, it means that there's a 99% probability that it is indeed true.
I
And
don't
if the
think
result that is being posted is in contradiction,
no, I don't think you under okay, you're taking it from another angle.
It's,
What I'm saying is
it's,
that
I think it's 0.5000 short. Or yes, more or
point
less.
you're saying 0.500
Zero less.
less. Why?
That's what I want to hear from you.
Okay. So, Prince, for your own answer, we don't have an hypothesis right now. Prince, do we have any
yeah,
hypothesis?
okay.
We don't.
Okay, obviously there is no hypothesis that is posted.
Yes, because you will see it written H naught. But this one, you just say you should calculate probability. That's what I asked you to do here. What is the probability? So I think who just answered that question? I didn't see the name because I'm not seeing the meet call and I can't see your name. So you have an idea.
His name.
Okay, good. But you don't know the reason why. The reason is because there are different Z tables. we have different Z tables. So there is a Z table of, like the Z table given in this case now. I'm trying to zoom out. What is wrong with this thing? So the Z table given to us now, if you look at it, it said the Z table is positive Z table. Here is the positive Z table. Okay, but this is actually not the positive Z table. I will show you the positive Z table. This Z table we are given is the table that runs from the negative to that. If I let me just illustrate it now. Give me a minute. Let me illustrate it. I believe you can see my board.
Yeah.
Yes, yes.
Okay, the Z table we are given is, this is what the Z table is showing us. Trying to clean all this. So the Z table is showing us that, let's say this is 2.5. This table is showing us the proportion, all of this region. Don't forget there is a 0 here, which is the mean of the Z-score. If it is positive, it means the value will be given will just be from 0 to this 2.5. That's the value we are expected to see, from 0 to 2.5. But what we are seeing on that table is from minus infinity to 2.5, the proportion of minus infinity to 2.5. So the correct answer is what they have in the solution, which is this, where is it again? Which is this guy, 0.4 something, which is this guy, 0.4938. This is the actual probability at Z equal to 2.5, and that should be between this region, this particular region, from 0 to 2.5. Are we following? So,
Yes.
and to obtain the
Yes, ma'am,
probability between this region from 0 to 2.5, just like what that other person said now, you subtract 0.5 from that value, 9938 minus 0.5, and that will give you that value, 0.4938. I'll show you guys a particular an online Z table that will help you to obtain any Z value, and this thing. I will share the link now. You can always, I use that a lot when I'm trying to work on anything that has to do with statistics. So I'm going to share that with you now, and I'll show you again how to look at the probabilities quickly before we take more questions. So I hope we are getting value from what we are discussing.
Yes, ma'am, we are.
Yes,
There is
we
a
are.
question from McDonald. I think
Yes, I've seen his
he was
question.
trying to ask.
Yes, I will come to it. I just want to
Okay.
quickly, I want to finish this part.
Okay.
So
Okay.
this is the Z calculator, the online Z calculator. Let me clear everything. So here is how it works. Somebody should mute himself. I don't know if it's Prince or who. I'm hearing myself. Okay, good. Let's give it the Z score of 2.5. Click on calculate. Now, can you see what you can? I hope you can all see this bell shape. Let me zoom my screen again. Can we all see this thing clearly?
Yes, we
yes.
can.
Okay, good. So in the first
Yes,
case,
ma'am, we can.
you can see this shaded region from negative infinity to 2.5 is somewhere here. The probability is 0.9937. This is what we are seeing on the table given to us in that notebook. So meaning that the probability that x, that particular whatever we're looking at, the x in our case now is the mean, the sample mean. The probability that the sample mean is from negative infinity to 2.5 is 0.9937, or the probability that the sample mean is from negative infinity standard deviation to 2.5 standard deviation is this, but this is not our interest. Do you look at the other situation? The probability that the sample mean is 2.5 away standard deviation from the true mean. This is the actual probability we are concerned about, this particular one here. and that is the value 0.062. If you check that solution, this is the answer. Here is the answer, and the answer is based on the question. What is the probability that the sample of 100 has a mean of 70 rands? That is, what the other way to ask it is, what's the probability that the sample mean is 2.5 standard deviation away, having calculated the z-score, and we obtain 2.5. So here is the image that depicts that particular question, and here is the actual probability 0.006, which is very, very small. Assuming we set an hypothesis, we would have accepted the null hypothesis to say that, okay, no, because we have sample of 100 and we got a mean of 70, we can't say that the population mean is 70 rands. Rather, we say 60. We are going to accept the null hypothesis in this case because we have a very small probability. Okay, now the other one, the 0.49, you can see this is the probability that the sample mean, or the sample mean is from 0 standard deviation to 2.5. You can see the region shaded, and this particular one is from the negative 2.5 to positive 2.5. That's the region shaded, and this particular one is either less than 2.5 or greater than either less than minus 2.5 or greater than minus 2.5. So with this particular tool, with this Z-score calculator, it will help you to get the probability of any Z-score. Any Z-score. Just impute the Z-score alone. Once you impute the Z-score, it will give you the different probabilities depending on your own situation or your own interest. If you want to use this first one, what you will enter is just enter the raw score. In our case, our raw score is 70. Enter the mean, the population mean in our case is 60, and enter the standard deviation. And the standard deviation in our case, I think, is 40 or 4 rather.
40.
40, which is 4. Now, when you enter those values, it will calculate the z-score. Instead of going to calculate it manually, you will get the z-score, which is 2.5. And not just calculating the z-score, it will give you the probabilities, and you pick the probability of interest. So I'm copying this link and pasting it on the chat. Oh, my keyboard is misbehaving seriously this evening. No.
This one's simple.
Yes, now with this, it will help you. It will make your life easier.
Yeah.
Yes,
Nandi,
yes.
This thing is a lifesaver. This tool.
Yeah, I'll copy and
Please
paste it on
post
that
it.
link. Yeah, right.
I've been racking my brain on how to calculate my probability.
No, you don't have to disturb
I tell
yourself.
you.
From the table, you can get the probabilities. But if you don't want to stress yourself, just use this tool to get the probabilities, and you are fine. Okay. Haven't done that. Let me look at this question and let's see how to answer it. Does a normal distribution imply that the observations are spread closely around the mean? Okay, good question. The normal distribution, it doesn't really imply that at a goal. Okay, it doesn't really imply that at a goal, but what it implies is that the variance is constant. That is what it means. It doesn't imply that they are closely around the mean, but it implies that their variation is constant. That's what normal distribution implies. The variation of each data point around the mean is a constant value. So, like if you look at the bell shape or the curve, what am I displaying now? What can you see, guys? Are you guys seeing my?
Nothing.
Okay. Let me stop and share again. I want to share my board. So if you look at this curve that we have here, let me just clean all of this blah blah blah. In fact, let me draw on that one. When you look at the bell curve, let me draw that again. So we say here's a normal curve, right? We have the mean. So what it means is that if the distance between this mean and this very point here is sigma. is the standard deviation, and the distance between this mean and this mean is also the standard deviation, the sigma. So it tells you that if there is a data point here, another one here, the distance from this data point to the mean will be the same thing as the distance from this data point to the mean. So the distances between one data point to the mean, to the left and the right, are always equal. That is what the standard, that is what the normal distribution, that is what it implies. Whenever you say a particular data follows normal distribution, what it means is that the variation is constant. But that doesn't mean that they are very close to the mean. Do you get? It doesn't mean they are very close to the mean. So if you want a situation where the data point to be closer to the mean, what you will then need to do, okay, let's look at the z formula again. Before we move on, let's look at the z formula. The z formula is this, or the z-score formula is x bar minus mu over sigma divided by the square root of n. Now this value right here, this value determines how big or how small the z-score will be. This value, the one I circled, determine how big or how small the z-score will be. Remember that when you have a fraction, say a over b, the bigger b grows, the smaller the whole fraction. For instance, 1 over 2 is
That's
0.5.
one listening.
1 over 3 is 0.33333, right? 1 over 4 is 0.25, right? 1 over 4 is 0.25. 1 divided by 5 is 0.2. 1 divided by 6 is 0.1666. So what do you notice? As n grows, the whole fraction is reducing. So as this guy in circle increases, the whole z-score also reduces, meaning that the level of spread of those data from the mean will always be reducing. So what do you think will cause an increase or decrease in this particular parameter I've circled? What will cause an increase or decrease is the number of n. The number of n will cause an increase or decrease.
That's the sample.
Yes, the number of the sample. So the more the sample you have, the tighter, the slimmer this curve becomes. The more your sample size, the slimmer it becomes. If you have something like this, if you increase the sample, it will go something like this. If you increase it, it goes something like this, and it keeps on, it keeps on going thin and thin and thin and thin. That is what the number of n does to a normal distribution. So I hope I've answered that question.
Yes, you have. Thank you.
You're welcome, bro.
Yeah, Mr. CJ, thank you so much. The time is fast spent, though it feels like we should go on because it's really, really enlightening the session. But everything that has a beginning has to have an end.
True.
I had a question actually, but I don't. We may not have enough time to attend to it. Actually, it's
Uh,
actually from the MCQ.
I
I
I
had
don't know.
attended to all of the MCQ's questions, but I was having a little challenge with question 10, so I wasn't really sure how
Okay.
it would be approached. But with the insights I have from this session, I would reattempt it again, and
Can you
hopefully
remind me? Can you remind me of
I
that
should be
question?
able to find. Okay,
Can
the question 10,
uh,
I have it right
what's it all
from.
about again?
Okay,
Is it the
for
one for
questions
confidence
8,
interval?
9, and 10, that is the one about the Nokia battery.
Is it about the
Yes,
confidence
how
interval?
confident can we be that this new phone, exactly, how confident can we be that the new phone lasts longer than the Nokia 3310?
That so
About the batteries
so
and
to
the
so to answer
confidence.
yes. To answer that
The
question,
level of confidence, I think that's what
yes,
you're being asked for.
yes, and what they're asking you indirectly is the probability. To answer that question, what you need to calculate is how many standard deviation away is the mean of the new battery from the population. You know, the mean of the population is 31, and the mean of the new battery is 33.5.
Yes.
So how many standard deviation away is 33.5 from 31? With that value, go to your Z table and compute. So that means you are going to obtain a Z score. With the Z score and this tool I've just shown to
Okay,
you,
I'll obtain a Z score, then go to the
yes,
Z table and
yes,
get
with
the
this, in fact,
corresponding.
don't use the Z table
Okay.
in our material, it will confuse you. With the tool, this particular link I've sent to you, just go
Mm,
there and impute
okay.
your
I
Z
can use
score.
the site now. I can
In
use this
fact,
resource that you
you can,
just
yes, you
posted.
can use it to even calculate your Z score and the probabilities.
Okay, okay, beautiful. Because that's just what was left
Ah,
for the
this is what they
MCQ
call
for
cheat
me.
sheets. This is
So
what they call cheat
thank
sheets.
you so much, Mr.
You're welcome, bro.
cheat sheet.
I told
Exactly,
you,
cheat
this is cheat
sheet.
sheets. Maybe those are they give us this cheat sheets.
So, guys, please, if there's any other burning question that we can quickly hand, just one question. Mr. Odukoya Daniel, thanks for being a part of this because you've been very very quiet. I've not heard you talk since we started. So please, guys, anybody who has a burning question, you can ask so we can call it a day. This session has been recorded by Mr. Isiche, so we'll have a recording of it. Hopefully, it will be posted soon enough so that those who wants to have it for reference purpose can always refer to it. So, any questions, please? I'll give 5 seconds for that purpose. 4, 3, 2. Okay, in the absence of any other question, I want to thank everybody for being a part of this session. I want to also thank Mr. Isiche for making out the time and for explaining these concepts really, really clearly. We deeply appreciate you. Please, I want to appeal to all of us. The one way we can show appreciation for this work is to actually use the rating function on Athena to rate anyone to rate each other generally. It doesn't have to be only the facilitators, but we should rate the facilitators for taking out time to out of their schedules to be able to come up with this. Because anybody who has done presentations of any kind knows that it takes a lot of preparation. I can tell you for free that Mr. Siche has spent a good number of hours preparing what he presented for it to be this clear and this informative. So please, the least we can do is to rate him. You can go to the Athena platform and rate him as being helpful because he indeed is helpful. We can also rate each other as well. So I really appreciate and also rate Mr. Dari because he too has also contributed greatly to the information that we have shared. So thank you guys. I think after now, right after this, I just want us to follow it line after line, precept after precept. We are supposed to go into the other statistic course. I think it is machine statistics or something like that. I can't remember what it is called. There is also another statistic train that we have not yet gone into. So we'll go into it. Probably the next session that we would run is going to focus on that. Sometime next week, we're going to also start looking at our predict and also maybe one or two ideas on how to tackle the exams. Python is the first course that has an exam after it. And unfortunately for us, nobody knows what the exam looks like since we have not done it. I just intuitively I feel that it will be time. Since all
Yeah.
our tests are not timed, the Python exam most likely will be timed. That is just a speculation on my part. So it would really help for us to do the necessary practices to put ourselves ahead when it comes to writing those exams. So I think we are done for today in the absence of any other question. I want to thank you all once again for being a part of this presentation. The links will be shared eventually on the platforms for those who would like to download and refer to it. Okay, so we'll see in the next meeting. Thank you so much, guys, and have a great night. Bye bye.
Yeah, Mr. Nandi, thank you so much. In fact, immediately Mr. Okun just mentioned that rating. I just went to click on Mr. Nandi as a helpful, as being helpful, 5 star. And Mr. Dare, you guys have been really, you have been really great. Please, that's a very good idea. Let's keep rating ourselves so that
All right. Thank you very much,
to
guys.
boost this pod.
Yeah.
Yeah.
All right. Good
Thank you, Mr.
night,
Nandi. We
guys.
try. I enjoyed today's lecture. Good night.
Good night, bro. You're
Good
welcome.
night. Thanks, Namdi. Thank you very much. Chooks Alpha.
Good night.
Good night.
I do.